Okay, so we are also looking at radical equation. Radical equation, that is sets involving equations. Good. So when you are given sets involving equation and you are asked to find the values or the value of unknown, then how we are going to solve these examples, that is how you go about it. So when we say radical equations, we are only talking about sets which involves what? Equations. Okay, good. For instance, I can give you, let's say, square root of x, which is equal to 4. This is what set involving what? Equation, and that is what radical equation. So what you do is, once you have the square root, okay, so one thing I want you to take note is, if I give you this, let's say if I give you x squared is equal to 4. If I ask you to find the value of x, when it is squared, you have to take square root of both sides. All right, so this one, you are going to write this, which is equal to, whenever you are taking square roots, then you should bring your plus or minus, then square root of 4, like this. Why plus or minus? Whenever you are taking square root, means that you are going to get two solutions. You are going to get what? Two solutions. That's why we have plus or minus here, so that at the end of the day, this one will go, then I'll have my x is equal to what? Plus or minus 2. Okay, another way, the reason why we are also getting plus or minus 2, meaning that we are getting two solution. This can also be done in this form. I can write this as x squared minus 4. Then I'll write x squared minus 2 squared, which can give me difference of what? 2 squares. Okay, x plus 2 is equal to 0, 0, like this. Okay, because I'm going to get x is equal to 2 or x is equal to negative 2. That is why we are getting this. It means we are getting two solutions. Have you gotten that? Good. So if you have this, this is how you go about it. But in a situation whereby you have the unknown in the root like this, and you have this, okay, what you do is, when it is in the square root, you only take what? Or you only square both sides, or take square of both sides. When it is squared, you take square root of both sides. Have you gotten that? So that this one will go, and I have my x is equal to 4. Note that this one you are not going to bring plus or minus, because you are not going to get two solutions for this. Have you gotten that? It's only when you are taking the square root, then you get two solutions. So take note of that. All right. If I give you this, x cubed is equal to, let's say, 8. It means that I will have to take cube root of this, so that this one will go, and then I'll have my x, which will give me what? 2. Have you gotten that? Great. If I have this, if I have x cubed is equal to 2, all right, or let's say is equal to 8. Already we have this, or let me say I have this, the cube root of x is equal to 2. So what this is, once I have the cube root, it means that I'm going to take cube of both sides, so that I'm going to get x, this one will go, which is equal to 8. The same way, if I have the fourth root, which is equal to, let's say, 2, it It means I'm going to take the fourth or exponent 4 so that this one will go. Have you got it? So it follows like that. When you are given in the root, you take it what? Reciprocal. Have you gotten that? We take the reciprocals. That's how it works. So for instance, if I give you this, then what I'm going to do is I'm only going to square so that I'll get my x is equal to what? 16. Have you gotten that? Good. So that is radical equations. Now let's go deeper. Okay. Now, if I give you this example, let's say you have root 2x minus 3, which is equal to 5. Good. If I give you this and ask you to find the value of x, this is also what? Radical equation. So what you do is, because you have square root, you only what? Square both sides. So this one will go, and then I'll have my 2x minus 3, which is equal to, so 5 squared is what? 25. I will just group like terms. Is equal to 25 plus 3. Then I'll have my 2x is equal to what? 28. I will divide both sides by my 2 to get my x as what? 14. Very simple, right? Good. So for radical equations, it's very, very simple. What you do is, whenever the root is given to you, if it involves roots, then you are squaring what? Both sides. There are times that you need to group some like terms before you square both sides. Okay. So let's take another example. Okay, so let's look at this example. So we have square root of x minus 3, and then minus 7 is equal to 0. So examples like this, before you can find the value of x, you need to group like terms. So we can maintain this here and then send 7. Have you gotten that? So that we get what? 7 here. After that, we can take square root of both, or we can square both sides, so that we have this here. Then we have x minus 3, which is equal to, so this is squared, which is what? 49. Now x is equal to 49 plus 3, which gives us what? 52. Alright, so you always have to group like terms. Sometimes when it is not grouped, you need to group like terms so that the work becomes very, very what? Simple. Other than that, you find yourself wanting. Alright, good. Now let's take this example as well. So for this one, we can also find the value of x by grouping like terms. So I can group like terms by maintaining this here, and then bring my 3 here to make negative 3, and send this here, so that I can have x minus 3. Because if I should group like terms, I'm just maintaining. Someone can also decide to keep this here and send this one there. How you group the like terms, at the end of the day, you are going to get the same solution. Okay, so I have decided to maintain this root x, and then I have brought the x here. Because it is positive, it gets here, it's negative, and this is negative. When it gets there, it becomes what? Positive. That's why you don't see the negative here again. Okay, so once it involves what? Square root, what do? You only what? Square. So as for this one, very simple. I said when it involves the root, you need to what? Square it, or take it reciprocal. Have you gotten that? Good. So this one, it means that this we are going to square. Now this time, this root doesn't affect the 3. This is separately. So what we are going to do is, we are going to open this bracket. So if you are opening the bracket, I said always we use the short trick, or the trick that we can use it. So what we do is we square the first term, the whole of the first term, and we take this as a whole. You take the exponent as a whole and multiply by this term, and at the same time by this term. So it is going to be 2, this exponent, you take it as 2 times root x times the same, the last term, which is -3. Then plus, then you square the last term. So this trick, what you do is square the first term, square the last term, take 2 to multiply the whole of the terms in the middle. Have you gotten the point? Please, whenever you are taking the square of the terms, remember the sign. If it is negative, put all of them in negative. Okay, you see that all of this in negative, and you square all of them. All right, good. Which is equal to this, the square root is affecting all of them, so this one will cross this, leaving x minus 3 behind. Okay, good. So this is what we have here now. Now if you square this, you are getting x. If you multiply this by this, then you are getting -6 root x. Then if you square this, you are getting what? 9, which is equal to x minus what? 3. Have you gotten that? So let's group like terms. Okay, I can decide to send this here and bring this here. So I can keep x here, bring this x here, so it becomes negative. Bring this 3 here, it becomes plus 3. Then maintain my 9, and then I will send this 6 here, which will give me 6 root x. Someone can also decide to maintain this 6 and then send the whole of this that side. It will all work. Okay, good. So because we have x here, we have x here, so this one will go. 3 plus 9 gives me what? 12, which is equal to 6 root x. Now once we have this, we can divide both sides by 6. Then this one will go, and then I'll have my 2. All right, is equal to root x. This time we still have another square root, so we take square of both sides. Then we have 4 is equal to x. Therefore my x is equal to what? 4. Very simple, isn't it? All right, good. So that is how we solve what? Radical equations. Now let's look at these 2 examples. Let's solve them as well. Good. So we are going to solve these 2 examples here. So the first one, let me begin with the solution. Good. So let's solve the first one. I'm going to solve the first one with you, then you also do the second example. Okay, good. So this is what we have here, minus, which is equal to 1. So questions like this, before you can solve, you need to what? Even though this is in the radical, this is also in the radical, so we say that radicals are at one side while whole number is also at one side. But to make the work easier, because this one is huge, this one is huge, this one is single, if you keep them here and square, though it can also work that way, but the work will become tedious. So instead we can decide to send any of these in the radical sign to the other side and pair with the 1. So this one I will decide to I will maintain x plus 7 here, and then send this to this side like this. When I'm done, then because it involves square root or radical, I will only take square, or I will only square both sides like this. So this one will go, and then I have my x plus 7, which is equal to, then I'm going to open this bracket. So the same principle follows the short form. So just square the first term, take this as a whole, and multiply by all of this. So 2 times 1 times the whole of this, the whole of 3x minus 2. And then after that, you square the last term. Square the last term. Square the last term like this. Have you gotten that? Good. So that we have x plus 7, which is equal to, so 1 squared is 1. Now let's multiply this by this by this. So 2 times 1 gives me 2. 2 times this gives me what? 2 root 3x minus 2. Okay? Alright? Good. Now, plus, so this one will also go. We have 3x minus 2. Like this. Good. So let's see if we can group some like terms. Now I have x here. So let me write x here. Bring this 3x here. Maintain my 7. Bring this 1 here. Bring this 2 here. And then I will maintain only this at this side. I've already told you how you do the grouping of like terms. Depends on you how you want to make the work easier for you. So this is how I decided. I decided to maintain only this side and send the rest here. How you do yours. All that you have to be careful is you look for the sign. If it is addition, it should be negative. If it is negative, it should be what? Plus. So that's what we are doing. Now we have here as this, when you subtract this, we are getting negative 2x. Now this one also gives me what? Plus 8, which is equal to 2 root 3x minus 2. I've forgotten that. Alright, good. So once we have this, then we can't group like terms again, because it involves a radical sign or square root. We take square of both sides again. We square both sides again. Good. So this time we are going to also square this. So I said square the first term. You square the first term, which I said negative 2x squared. Then you take these two, multiply by negative 2x and multiply by 8. Then you square the last term, which is 8, which is equal to, then let's square this. This one too, we are going to square this. So this 2 squared times then the whole of this squared, like this. Have you gotten that? Good. So if you are squaring this, then I'm going to get 4x squared, because the square will affect all of them. It will affect this 4 and then to affect this. Now let me multiply this. So 2 times this. Okay, 2 times negative 2x gives me what? Negative 4x. Negative 4x times 8 gives me what? Is it negative 32x? This one we are supposed to square it, plus 64, which is equal to, so 4 times this gives me what? 2 squared gives me 4. Then this one will cross this, so we have 3x minus 2, like this. Have you gotten that? Good. Very simple. All right, if you follow the principle, it goes like that. You take your time and then you work with the thing. You see that it will be very, very what? Simple. Now let's open the bracket here and see what we do. So we have 4x squared minus 32x plus 64, which is equal to, let me open the bracket here. So 4 times this gives me what? 12x and then minus what? 8. Now let me group like terms. So I'll have my 4x squared minus 2x then this one 2 minus 12x plus 64 plus 8, which is equal to 0. All right, so we have 4x squared. Now 32 plus 12 will give me what? Is it 44? So minus 44x, then 64 plus this gives me what? 72, all divided by all is equal to what? 0. Now looking at the figure, let's check if we can reduce it small. Okay, good. So if I'm to reduce this, then I can divide each term by 4, and then I can get x squared minus 11x plus 18, which is equal to 0. So we have quadratic equation. So how do we find quadratic equation? Quadratic equation, what we are saying is we can use factorization method. We can also use quadratic formula. We can also use completing squares, but in this case we are going to use factorization method. So if we are using factorization method, then we are going to find two numbers. When we multiply, so we find the coefficient of this and multiply by this, we get 18. So the 18, we find two factors. When we multiply those two factors, we must get the 18. When we add those two factors, we must get what? Negative 11. So looking at this, then we can write here as x squared. If you are using factorization method, then I can write here minus 2x here. All right, and then minus 9x plus 18, which is equal to 0, because if this 2 and 9, they are factors of 18. When I multiply this negative 2 by negative 9, I'm going to get 18. When I add them, I'm going to get negative 11. Is that not so? Right, good. So what I do is I can only factor this out, and then I will have my x minus 2, and then I can also factor plus, or let me write negative 9, and then x minus 2, which is equal to 0. So I can have x minus 9 and x minus 2 equals 0. Therefore, now my x is equal to 9, or x is equal to 2. Now we have two solutions for this, but the two solutions, we have x is equal to 9, we have x is equal to 2. So what you do is, after getting the solutions, substitute these values into the main question and see if you get your solution is true. So we put 9 here, and see if you get the 1. When we finish, we put 2 here, and see if we get the 1. So the one that satisfies becomes your solution. If 9 satisfies this, then 9 is our solution. If 2 satisfies this, then 2 is our solution. If all of them satisfy, then the two of them are our solution. Have you gotten that? So let me first put 9 there, and let's see. So in the question, we have x plus 7. So I will put 9 plus 7 minus, then 3, 9. All right. Okay. Minus 2. Let's see if it is going to be equal to 1. So we know that this is 16 minus, so 9 times this gives me what? 27 minus 2. So we have 25 is equal to 1. So here is 4 minus 5 is equal to 1. Now we are getting negative 1, which is not equal to 1, because we have negative 1. So it means 9 is not the solution. Now let's try with the 2 and see. So for x we put 2 here, plus 7 minus 3, 2 here minus 2, which is equal to 1. So we have here as 9 minus this times this is 6. So we have 4, okay, which is equal to 1. So square root of 9 gives me 3, square root of 4 gives me 2, which is equal to 1. So we have 1 is equal to 1. Good. Since the 2 satisfies the condition, then therefore the solution is given as x is equal to 2. So the value for x is 2. That is our solution. Have you gotten that? That is our solution. Yes. So whenever you are asked to find or solve equations involving radical signs, after working out, don't leave there. Don't leave your answer like that. What you do is substitute the solution back, or substitute the solution into the main question given to you. If any of the answers satisfies the condition, satisfies it, then that will be your solution. You see that we got 9 and 2, but when we put the 9 in the question, we realize that the answer we got at the left side wasn't the same as the right side. For that matter, the 9 cannot be the solution, even though we got 9 as x. But when we substituted the 2, yes, we got it right there. We got 1 at the left side, which is the same as the 1 at the right side. Therefore, the solution is rather what? 2. Have you gotten that? So that is how when you are asked to solve equations involving radical signs, that's how you go about it. Now we have solved the first example, so I'm going to leave the second example for you to do it. You follow the same principle. All right, so this brings us to the end of set. So in our next lesson, we are going to start a new topic, that is what? Relations and functions. So start revising on relations and functions, so that when we get there, everything will be easy for you. All right, so thank you for your time. This is Maths TV. Don't forget to subscribe, like, and share. Now see you next time. Thank you.